Hello everyone, welcome to another session of GMAT by example. Today we are going to talk about number properties, specifically even and odd integers. Now these are very simple and straightforward concepts, but the questions on them can be very tricky, and they lull you in the false sense of, hey, I know this thing, and then they throw a trick at you and you get it wrong. So if you already think that you are pretty good at even and odd integers, let me give you an example and see what your reaction to it is. So let's start with this question. You're given an expression, right? It is t to the power of 6 minus 13 whole raised to the power of 12 multiplied by t cubed plus 4 whole cubed. And we are asked if it is even. Now, how will you approach this question? Right? This can be a data sufficiency question. This could also be a problem solving question in actual GMAT. And if you're feeling worried about this, if you're feeling overwhelmed with the amount of powers there are in this question, then this tutorial is going to help you. So please pay attention to the various concepts discussed in this tutorial. In the next part of this tutorial, we will actually go through 4 or 5 really good even and odd examples and apply these exact concepts and keep referring back to this tutorial to kind of reinforce how to solve the problems involving even and odd integers. Before we go any further, let me reiterate and remind you that number properties is a huge topic. Just for integers alone, there are so many topics. There is even and odd, positive and negative, stuff on the number line, their factors, prime, co-prime numbers, HCF, LCM, tests of divisibility, and this is all just for integers. There's going to be a separate tutorial for kind of non-integers part of the number properties as well. And let's not forget about zero, right? That single thing can throw a wrench in any question, and we will come to that. So in today's session though, we are focusing on this small topic of even and odd integers, and we are going to understand it, and we are going to really go in depth on how to solve even and odd integer questions. What is the framework? But before that, we need to start with certain concepts. Okay, before we go any further, please join my Facebook group. We have a lot of free webinars which I personally give. There are videos, tutorials, and a lot of really helpful questions being posted by everyone in the community. The link is in the description. Please don't forget to join. It is again free. And also please do not forget to like the video and subscribe to the channel. YouTube only gives me credit for doing good work if you guys like and subscribe. And so a small request there before we get to the meat of the video. All right. Without further ado, let's start with integers, specifically even and odd. Let's talk about integers. What are integers? They are numbers with no decimal values. So 2.2, 3.4, they are not integers. Integers can be positive or negative or neither of them. Minus 100, minus 3, 0, which is neither positive or negative integer, 15, 134, these are all integers. Nothing new, all of you probably already know this, but it's a good place to start with. Now let's talk about even integers. So even integers are all integers that are divisible by 2. In other words, when I divide an integer by 2 and it leaves 0 as the remainder, then that is an even integer, right? So that is one classification of integers, even and odd. Minus 14, 4, 26, they are all even integers. Now then, what are odd integers? So anything that is not even is automatically odd. In other words, all the integers that are not divisible by 2, which means that when you divide them by 2, they leave a remainder of 1, because that's the only other remainder possible when you divide anything by 2, then it's an odd integer, right? So even and odd is just one of the ways you classify the integers, and Here, minus 13, minus 1, 21 are all odd integers. Remember, even and odd can be positive or negative. So one important thing to note here and remember is that even and odd concept is applicable only to integers. So if a number is given to be even or odd, then you can automatically assume that it is an integer when it is given, not when it is asked. So there is a slight difference here, right? If I say x is even, then you know x is also an integer. But if I ask a question, is x even, then you don't know anything about x. It could be an integer, it could be a decimal. We don't know. So here is the $1,000,000 question, right? So integers are numbers with no decimal. What about 0? Is it even or odd? We talked about 0 being an integer, but what about 0? So when you divide 0 by 2, you get a 0. So 0 is an even integer. By definition, it is divisible by 2, hence 0 is classified as an even integer. Okay, so next we are going to look at the operations of even and odd integers like addition, subtraction, multiplication, division, powers. That's because a lot of GMAT questions utilize this set of rules and sometimes they could be bamboozling. So let's have a look at them, right? Let's start with addition and subtraction. What do we know? When you add and subtract an even number from another even number, you always get an even number. For example, 12 plus 14 is 26. So you add an even to an even and 26 is also an even. Similarly, you subtract 8 from 8 and you get a 0. Again, even minus even is even because we just learned that 0 is also even. When you add or subtract an odd number from or to an even number, then you get an odd number, right? It doesn't matter what the order of it is. So it could be odd plus even, or it could be even plus odd. That doesn't matter. In the end, the result is odd. So 12 plus 13 is 25. 12 minus 13 is minus 1. In both cases, you are adding or subtracting an odd number to an even number, and you're getting an odd number. And finally, when you add or subtract an odd number from or to another odd number, you get an even number. So 13 plus 13, for example, is 26, and 1 minus 11, for example, is minus 10. Simple enough, but can this be a little more complicated? Absolutely, it can be. So what about if you're given more than two even and odd numbers in an addition or subtraction chain? Something like this: even plus odd, minus another odd, plus another even. What do we do? So basically, you just take them two at a time, right? And apply the same concept. So in this case, let's take the first two. We know even plus odd is odd, so that will be an odd. Forget about everything else. Odd minus odd is even, so that would be even. And the last one, which is even, kind of let it stay right there. We'll come back to it. Let's take this pair now. Odd and even is again odd, and we are left with another even out there. So let's add these two. Odd and even should be odd. So the answer to the question is odd, and got to that answer by combining them two at a time, right? Fairly simple framework to actually solve these kind of problems. So there is another method. Yes, absolutely, there is another method. And what is that method? Count the number of odds, because they are the ones whom are going to make all the difference, right? So if you think about the properties, you add even to an even number, it just gives you an even number. So they're not adding anything. If you add an even to an odd number, it gives you an odd. So if you just count the number of odd numbers, in this case, we have 1 odd, 2 and 3 odd numbers. So we have odd number of odd numbers. In that case, when you combine all three of them, you get another odd. So now when you have other even numbers and one odd number, what do you get? You get odd. You can say odd minus odd is even, and even minus odd will be odd. So take it as a rule of thumb that odd number of odds will give you odd. And when you add any odd to any number of even numbers, you will always get odd as an answer. So the answer to this question is odd. We did it in one step. right? So method 2 is a little faster than method 1, but either of them will help you. It's not going to make a substantial difference technically in the problems on GMAT. So once you practice, you can practice with both the methods, but use the method you are more comfortable with. Hopefully, the concepts around addition and subtractions are clear now. If they're not, do not worry. You can always rewind the video and listen again. But important thing is to practice. So now we move on to the next operation, which is multiplication. Similar to addition and subtraction, we will start by taking two terms at a time and then expand to larger expressions. So when you multiply an even number with another even number, you always get an even number. For example, 4 multiplied by 2, both even, equals 8. 8 multiplied by 0 is 0, and 0 is even. We already saw that. Similarly, when you multiply an even number with an odd number, the product is still an even number. For example, 2 multiplied by 13 is 26, and 0 multiplied by 13 is 0. And finally, when you multiply an odd number with an odd number, you get an odd number. For example, 13 multiplied by 13 is 169, all three of them being odd. 1 multiplied by 11 is 11. As you can see, to get an odd number, all of the integers must also be odd. Otherwise, if an even number is present in the product, then it becomes even. As you can see, to get the product as odd, all integers must be odd. Even if a single even number is present, then the product would be even. So now let's look at an expression which has a lot of numbers. Something like this. As you can see, we have a lot of numbers. How do we figure out whether the product will be even or odd? It's a very simple rule, and it is if any one of the numbers is even, then you can forget about the rest of the numbers. The product will be even. Something like this. So in this product, the first number itself is even, which means that the product will be even. You can ignore the rest of the integers because you have figured out one of the numbers is even. Let's look at another example. Here, the last number is even, and that should be sufficient to tell us that the product will be even again. You don't have to look at the other numbers or find any kind of products. Not even a single integer is even in the last one, which means all of the numbers are odd, so the product will also be odd. That's it. Very simple, right? So the next operation that we talk about is division. Division for even and odd is a little more complicated, but the good thing is it's usually not a very popular topic for GMAT questions. But for the sake of covering all bases, let us cover this topic as well. So first, what happens when you divide an even number with another even number? The result could be an even number or an odd number or even a decimal. I have given two of the examples here, two of the three possibilities here. 6 divided by 2 is 3, so an even divided by even is an odd. And 4 divided by 8 is 1 by 2, which is 0.5, a decimal. What happens when an odd number is divided by an even number? It is always a decimal. For example, 3 divided by 2, 1.5. 15, an odd number, divided by 4, an even number, is 3.75. So when an odd number is divided by an even number, it is always a decimal without fail. Next, when you divide an even number by an odd number, you can get an even number or a decimal, but you will never get an odd number. For example, 6 divided by 3 is 2, an even number, and 6 divided by 9 will be a decimal, but you will never get an odd number. And finally, when you divide an odd number by an odd number, you can get an odd number or a decimal, but never an even number. For example, 13 divided by 13 is 1, another odd number, or 1 divided by 11 is actually a decimal number. Okay, so we have one other operation left. powers or exponents. And this is an important one. So pay attention. So the way the powers works is this. Even to the power of any positive integer gives you an even number. Odd to the power of any positive integer gives you an odd number. And any non-zero positive or negative number to the power of 0 is 1. Any positive or negative doesn't matter. Non-zero number to the power of 0 is 1. If you notice, I have written number here instead of integer because what I wanted to emphasize is it doesn't have to be an integer. 2.2 to the power of 0 will also be 1. But since we are talking about integers here, you can keep the reference of integers, but this property applies to non-integers as well. And finally, 0 to the power of 0 is not defined. So that is completely out of GMAT scope. If you find yourself in a situation while solving a problem where you're getting 0 to the power of 0 as one of the solutions, then something is amiss in your approach and you're going in a wrong direction. Simple enough? But know that this is extremely powerful. The implications of this will make complex questions look like a piece of cake. Now that we are armed with all of these concepts, addition, multiplication, subtraction, division, and the powers for even and odd numbers, let's review the question that we started with. So let's reread the question. For integer t is t to the power of 6 minus 13 raised to the power of 12 multiplied by t cubed plus 4 whole to the power of 3 even. And we just learned that any even number to the power of any positive integer is even, and any odd number to the power of any positive integer is odd. What does that tell us? The big thing it tells us is that the non-zero powers, right, positive integer powers, do not add anything new to the expression. Even remains even, odd remains odd. So to determine if an expression is even or odd, I can almost ignore the powers and not worry about them, and that will simplify everything. Let's see how to apply this concept in this particular case. So in t to the power of 6 minus 13 raised to the power of 12, I can ignore 12 because 12 is not going to add or change what t to the power of 6 minus 13 is. If it is even, it will remain even. If it is odd, it will remain odd. So let's forget about 12. That gives us t to the power of 6 minus 13. Now again, t to the power of 6. 6 is not adding anything to the overall expression because if t is even, t to the power of 6 will be even. If t is odd, t to the power of 6 will also be odd. In other words, I can even simplify it further and ignore 6 and get t minus 13 as my simplified expression. What I'm essentially saying here is that t minus 13 being even or odd ultimately determines if t to the power of 6 minus 13 raised to the power of 12 is even or odd. So why not just work with the simpler expression rather than the more complex one, right? All right, so similarly, we do the same thing. We ignore the cubed in t cubed plus 4 whole cubed. We again ignore the 3 in t to the power of 3 and get to the expression of t plus 4. Again, what we are saying is the simplified expression t plus 4 being even or odd ultimately determines whether t cubed plus 4 to the power of 3 is even or odd. So instead of working with the more complicated expression, why don't I work with a simpler term to make our lives easy, which is t plus 4. Now essentially we have brought the whole big complex expression down to two very simple terms, t minus 13 and t plus 4. And the question was, is the product of these two numbers even? Now, based on what I'm seeing, I already know the answer. But let's take it one step further. since we do not know if t is even or odd. So let's just assume t to be even at first and see what happens. So if t is even minus odd, t minus 13 will be odd. So t minus 13 will be odd. And since t is even, t plus 4, even plus even, will be even. And we have to find the product of these two. So since one of the numbers is even, or one of the terms is even, the eventual product will be even. Similarly, if t is odd, t minus 13 will be even, and t plus 4 will be odd. Again, one of them is still even, so the product will be even. So that gives me the answer to the question is yes. The expression, the given expression, is in fact even. So we were able to simplify the question so much that all the complication basically melted away. And we have a very simplistic expression, and we were able to figure out the answer in no time. And that's the trick to solving even and odd kind of problems. So do you think now you have got what it takes to solve even and odd problems? Test yourself in my next video. We will go through some of the examples, tough as well as easy ones, and see if you are able to solve them before you see my solution. Please join my Facebook group, and also please do not forget to like the video and subscribe to the channel. YouTube only gives me credit for doing good work if you guys like and subscribe.